Hey everyone, I'll bet you never thought of this. I'm using my copper, recycling it, to use for my cathode, and the anode's actually a stainless steel plate. You can't see it in the bottom, but I covered it all in my cementing dust because I didn't want to melt it down. I'm trying to save money, save process costs. So, have a look at this episode and I'll show you exactly how I do it. So what am I doing here with this stainless steel? Well, my anode weight, the wire broke off it through electrolysis. So I'm going to insulate it with a little bit of plastic, heat shrink, and see what I can do. So let's get on with it. Now with this experiment, I'm trying to stop the copper eroding very, very quickly and eating the connection away. So, a new approach. Let's see if this works. Make sure it's right down on there and lightly heat it. Just so it shrinks around. We'll give it a bit more heat. That's simple. Don't need a blowtorch. Make sure we get it around all edges. I don't want this eating it away. So I'll hold it here while it's hot. Let you see what's going on here. So we've got a connection here, sealed connection. And that's going to go into the bottom of the bowl. You'll get to see the concept and what I'm talking about here. This disc is to go into the bottom of the bowl. Here, my cathodes are going to absorb the copper. I'm going to pile all my cemented material here. I'm not going to use a basket. I'm just going to pile it all on here and see what happens to it. Now, I'm going to keep it away from the back here because there's a couple of millimeters under there. I couldn't get it to the bottom. So, if any falls against the edge here, I've polished the edge so that any material will eventually dissolve the copper out. Now, this is a new design, new idea. That's what I'm all about. Taking it from a different perspective. Let's see what does. Power supply is cranking along just fine. I've got that bridge rectifier over here attached to the aluminium on the fan because it is drawing higher current than what I expected. Just keep it cool, you'll be alright. Okay, so I've come out here a bit later and the current seems to have settled down to a normal level. Like I say, the electrolyte has to equalise or find a happy zone. See all the cemented copper there? I made sure it covered that anode plate because I didn't want power leaking through and not doing anything. I didn't want to leave it all bare. So yeah, it looks like it's coming together. The liquid has got a little bit bluer over time. And yeah, just have another look at the amps. And we're leveling out. Yeah, look, that's great. That's fantastic. So we'll see how this experiment goes over the next couple of days. I'll give you some updates, quick updates on shorts, and see how much copper we're actually plating out onto these cathodes here. And I will throw more material in here after I reduce a lot of this down, and I will show you how much I do reduce down. Just a normal computer power supply. I'm utilising that bridge rectifier to drop the voltage. Now if you want to have a look at that, I do have a video on creating the perfect voltage for plating out copper. Simple solution, doesn't cost much. I've got about 5 of them in the shed, so that's the way we're going with it. With the cathodes that I'm using, I've actually got a really deep one here to get any copper that's sinking down to the bottom, stratification. And I've also got one here right at the top as a test piece, just so I can see exactly what's going on. Look, I'm coming out and stirring it every couple of hours just to see how it's going, but nevertheless, this will give me a true measurement of how much copper I'm plating out on what level. Just something to be aware of and something to watch. Simple, but effective. If you like this kind of content, please like, share or subscribe. I'll give you updates on this over the next few days and we'll see where we end up.